In this reaction, we're going to learn how to classify chemical reactions. Now, you might recall that in an earlier lesson, we learned that there are two parts of every chemical equation. We have the reactants, which are the ingredients or the substances that exist before the reaction. The reactants are always written on the left side of the arrow. And then on the right side of the arrow, we have the products. The products are the substances that are produced by the reaction. So that's what's produced or what's made over the course of the reaction. We always write the products on the right side of the arrow. This is important to remember as we go forward in classifying reactions into these 5 types. Hopefully by the end of this lesson, you'll be able to classify almost any reaction into one of these 5 main types of reactions. Now, the first one that we're going to talk about today is synthesis. Some textbooks call this combination, but most chemists call this synthesis. And that's because we're taking two reactants, two things that are on the left side of the arrow. We're just calling them A and B here, and we synthesize them, or we combine them into one product. And we're representing that with the AB, where, as you can see, they're combined together. Now, the way to recognize a synthesis reaction, it will always have one product. So it might have 2 or 3 or even more reactants, but it's always going to have one product on the right side of the arrow. Now, the opposite of synthesis is called decomposition. And a decomposition reaction is when you have one reactant, so we're going to represent that with AB, and it essentially decomposes. It breaks down into 2 simpler substances. We'll just call those A and B. Now, sometimes those 2 simpler products are elements. Sometimes they're just simpler compounds. But a decomposition is where you have one reactant, always has one reactant, and it's breaking down into 2 or more simpler products. So we have synthesis and decomposition. It looks like they're basically the opposite of each other. The third type of reaction is called single replacement. Some textbooks call this single displacement. It's the same thing. In a single replacement reaction, we have 2 reactants, an element, which we'll represent with the letter A here. We'll call that the element. And then we have a compound, which we call BC here. So an element is being added to a compound. It's usually an ionic compound, although it doesn't really have to be. And what happens is A kicks out one of the elements in the compound. So in this example, A is kicking out B. And so B has been kicked out on the product side. It's all by itself. And A is pairing up with C. So that's a single replacement reaction. Now usually there's quite a bit of energy involved and often released in a single replacement reaction. In fact, a lot of these reactions generate or have the capacity to generate quite a bit of electricity. And so most batteries are based upon single replacement reactions. There's a whole branch of chemistry called electrochemistry, which is mainly focused on these single replacement reactions. Now, kind of similar to this is a double replacement reaction. And notice that it's a little bit more complex. We have 2 ionic compounds in a double replacement reaction, and that they generally need to be ionic compounds. And essentially they're just swapping partners. And so we have AB and CD, those are our compounds, and they just do a little switcheroo here. So A pairs up with D, and so that's why we have AD over here on the right side, and C pairs with B, and so that's why we have CB over there. So the 2 ionic compounds basically just swap partners, they swap ions. Now a 5th type of reaction is called combustion, and this is a very important type of reaction. This is a very important reaction for living things, for life. This takes place in our bodies. Anytime you burn something, there's combustion taking place. And essentially a combustion reaction, almost all combustion reactions look pretty much the same. They look like this. They have this CH or sometimes a CHO compound. We call those hydrocarbons. So these are called hydrocarbons because they have hydrogen and carbon in them, hydrocarbon, sometimes some oxygen. And they combine with O2, which is oxygen gas. And the neat thing about combustion reactions is when they are carried out completely, the products are always the same. The products are always carbon dioxide and water. And so it's really easy to predict the products of a combustion reaction, as we'll see later in this chapter, because the products are pretty much the same. So combustion reactions are easy to recognize, and they're very common. This takes place in our bodies, for example. You eat food that has glucose or some other type of carbohydrate, some kind of hydrocarbon in there, and you breathe in oxygen, so that's oxygen from the air, and then your body uses that. You have the processes of metabolism and cellular respiration, and then you exhale carbon dioxide gas. And you also exhale some water vapor too, at least a little bit of it, and that's why you can fog up a mirror, because you're exhaling water vapor along with the carbon dioxide. So this is just one example of combustion, but combustion is a very important set of reactions or type of reaction. There are some very common hydrocarbons. CH4 is a very common one. That's called methane. That is found in natural gas lines. Another one that's very common is propane. There are lots of people who heat their homes with C3H8. That's propane. Or perhaps they light a barbecue using propane. Here's another one that's very common. C4H10 is called butane. And so a lot of small lighters, like people use to light a fire, a barbecue, or like a small personal lighters, those have butane in them. These are all hydrocarbons. Here's another common hydrocarbon, C6H12O6. That's called glucose. And if you've studied biology, you probably know all about glucose. So those are just some common hydrocarbons. There are lots and lots of them. Well, let's do some practice here and try to classify these reactions. So here's the first one. And if you look at that, what you want to identify is the fact that there's one reactant. And so if there's one reactant, and it looks like it's breaking down into two or more products, we call this decomposition. So this is a decomposition reaction. Here's another example. In this example, we have an element, zinc, reacting with a compound, hydrochloric acid. An element and a compound, when combined, are a single replacement reaction. So hopefully you said single replacement when you saw that one. Here's another example. Magnesium and sulfur creating magnesium sulfide. Well, we have two elements combining into one compound, so that's called synthesis. So we have a synthesis reaction. Here's another one. C3H8, I think we said that was called propane, and it's reacting with oxygen to make carbon dioxide and water. Do you remember what type of reaction that is? I hope you said combustion. Remember, in a combustion reaction, the products are always the same, carbon dioxide and water. One more example. We have aluminum chloride and sodium hydroxide, and we make sodium chloride and aluminum hydroxide. Well, in this reaction, it looks like the ionic compounds have ions that are just swapping partners. Sodium gets with chloride and aluminum gets with hydroxide. So that's called a double replacement reaction. Double replacement. Some textbooks call that double displacement. So hopefully, at this point, you're able to take any simple chemical reaction and classify it into one of those five main types: synthesis, decomposition, single replacement, double replacement, and combustion.